Right, let's do this. Forgot what the start is. Oh yeah, I know there's one note I wanted to make right at the start. So we went over the syllabus. I don't think I showed it off in this lecture. Forgive me if I forget what happened in what lecture. 3 back-to-back is tough for my brain. But I'm pretty sure I didn't mention this in this lecture on Monday. But we're done with the syllabus. As long as you know everything that's in there, you can collapse it. Even when you refresh, it'll stay collapsed. And then you don't have to scroll past all that to get to the schedule. So we're here on day 1. And I apologize, I had dash slides here for course introduction. That shouldn't have been there. I don't have slides for day 1. Those of you asking me where the slides were, there's no slides for day 1, but we do have slides for today. And hopefully I'll get slides for Friday up before Friday. And when we have lectures with slides, which will be most lectures, I'll post them on the course website before lecture. At the very latest, they'll be posted by 1 p.m. And if they're posted right at 1 p.m., you know I'm frantically trying to get them together. But they'll be posted by 1 p.m. before my first lecture. And I'll lecture off of the course website slides. So at the beginning of each lecture, you'll see me download the slides like this, even though I just downloaded them an hour ago, just to make sure that what I have posted is exactly what I'm presenting in the class. It used to bug me when professors would have something like old version of their slides posted and then they'd be presenting from their new version. I like to make sure I don't make that mistake at all, so I'll download it from the website right before lecture. You have the exact thing, the exact same document, bit for bit, that I'm presenting with, available to you. Okay. Any quick questions before we jump into it? Let's do this. We got a lot to talk about today. It's going to be a fast-paced lecture. These first 3 lectures, where we're basically covering 115 but in Java, they go fast. It's going to be a very fast pace. And then next Wednesday is when things will finally start slowing down, when we talk about some 116 goodness. So here's our very first Java program, Hello World. All it does is print Hello Java to the screen. That's it. Doesn't do anything else. And there's quite a bit here to talk about. It's going to take us quite a bit of time just to get through Hello World. It's as simple of a Java program as it can get. I mean, I guess we could trim out a little bit. Just the package declaration is the only thing we can get rid of here. But it's pretty much a bare bones Java program. And there's still quite a bit of complexity here. This is why one of the reasons why we don't like Java in CSE 115. It's why we wait till at least semester 2 before throwing a language like this at you. Those of you who've had Java in high school, you know all about this, but this as your very first code on day 1 of 115 is a bit overwhelming. Day 1 of content, at least of 116, y'all can handle this. We'll just get through each part of this. Each section that we go through, each part of this program that we go through, I'll give a quick overview of it today, just enough to get us through this and get started with Java. By the end of the semester, and really by the end of about week 3, you're going to know about all of these words. Every word on the screen you'll know in quite a bit of depth. Today, we just want to do enough to get you off the ground. So let's break this down. The very first thing we see is a package declaration. This declares what package this code lives in, and you can think of your packages as a one-to-one correlation between your directory structure. So all of your code, I won't have time to do an IntelliJ demo today, by the way. I think Friday I'll fit it in. But when we get to IntelliJ and you get to your code, you'll see all the code is going to be in an SRC directory, for short for source. That's where all your source code goes. And then relative to that directory, the package declaration tells you where to find that code. So your package declaration is going to match your directory structure within the source directory. So we have package week 1, meaning this code is in a directory source/week 1. So if you think it's package declaration as directory structure, I'm not going to get mad at you at all. Next, we have the name of a class. We're declaring a class. We'll learn all about classes on week 3. Week 3 is the classes week. For now, sufficeth to know that everything in Java, all the code you write, all the functionality you implement in code, has to be in a class. All your code, aside from package declarations and import statements, All your code is going to be in classes. And we don't have to worry about it much further than that today, but everything is in a class. The name of the class is going to match the file name of this file where this code lives. So this class, we're to have a file defining the class Hello World. That's going to be in a file called Hello World. If we combine that with the directory structure, this code can be found in source/week1/helloworld.java. In Java, each class correlates one-to-one, just like packages, correlates one-to-one with files. So if you have a file named helloworld.java, Java is expecting that file to define a class called Hello World. If you name the file helloworld.java and the class maybe Hello World with a lowercase w, Java's going to complain and say, what's going on? Your file name doesn't match your class name. So a file defines a class. The file name has to match the class name. It's in a package which matches the directory structure. So whenever you're looking at code like this, as long as I'll leave off the package declaration sometimes, but if you see code like this in the slides, you know, go to that GitHub repo at the top of the course website. You know you can find this code in source/week1/helloworld.java. That's exactly where this example lives in the repo. So each time I show an example in class, you know where to find that. I'll leave off the package declarations as we get going. I'm not going to put that on every example, but they're usually going to be week 1, week 2, week 3. You'll be able to find that code. And if you can't, hit me up in chat, raise your hand. I'll let you know where the code is. Oh man, a typo already. I missed that one. And next is our main method. So this, first, what we would call functions that are declared inside a class are called methods. We call those methods if it's a would-be function that's defined inside a class. All your code in Java is in classes, therefore we don't have any functions. Got no functions in Java. Everything's going to be a method. So you'll hear me say method all throughout the semester. You're not going to hear me say function unless I slip up. Sometimes I do. If when I say method, you hear function, I'm perfectly fine with that. I'm not going to get mad at you at all. But when I say it, I'm going to stick with the correct, to the best of my ability. Sometimes I'll slip up. I'll stick with the correct terminology and call them methods. But methods, if you think of that synonymous with functions, cool. So main method is a special method that's going to be the entry point for our program. Running a program in Java or running a class is the same as calling the main method. Java's going to run your main method. That's how you say, Java, this is where my code is. This is how you start my program. This is different than Python and JavaScript, where each program, each file was just interpreted as a script, and it would just run all the code in your script. If in Python you created a file that just said print hello Python, if JavaScript you created a file that just said console.log hello JavaScript, that just runs and you don't have to do anything else. In Java, you have to create a class, you have to create a main method, and the main method has to look just like this. So let's break this down. Again, I'll go through each one of these words very briefly today, but we will get into each one of these keywords much more in depth as the semester goes on. So static, this means the method can be called without taking any additional steps. So static is the closest thing Java has to a standard function that you've worked with in 115. It just means you can call this method. That's it. If it's not static, we'll talk about non-static methods later in the semester. It means you have to instantiate an object of the type of the class where it's defined and then call the method through that object. We'll get to that. That's week 3 content, though. Right now, everything we see is going to be a static method. All methods we see will be static. So they're easier to call, and we don't have to think about what objects are quite yet. Void means this method doesn't return anything. Main is the name of the method, and it has to be, if you want a main method, it has to be M-A-I-N, all lowercase, to tell Java, this is my main method, this is where my program starts. This method must take as a parameter this string array. It must take strings as a parameter, and it must be public. So public means this code can be accessed from anywhere, specifically anywhere in your project. If you have code in another package, in another class, that code can access public code elsewhere in your program. Somewhere else, another project is using your code. It has access to your public classes and your public methods. And Java itself has access to your main method, so it can call your main method because it's public. So your main method has to be public, so it can be ran in Java. So is that a bit much? That's just the very brief overview. I could spend probably 2 or 3 lectures on just everything, every keyword that's here, explaining them all in great depth. This is a big reason why we don't like Java in 1.15. There are other reasons. There's a lot that goes into that decision. We actually used to do Java in 1.15, and I'd never liked it. But that's a lot just for Hello World. We haven't even done any code that does stuff yet, and that's a lot. So your main method, if you want a main method, if you want an entry point to your program where you can right-click your file and go run, and actually run code, you have to have a main method, which has to be public static void main with all lowercase letters, string array with a capital S and the brackets after it. The only thing here that can change is args. That is a variable name, but args is pretty standard across the industry. It's pretty much always called args. We're never going to use those strings, so don't worry about those. I believe in 2.20 you will, not in Java, but in C. But that's what we call command line parameters. We're not going to use those at all in 1.16. But we still have to have that as part of our main method definition, or else Java won't know what to do. It'll say, where's your main method? You don't have a method named main that's public static void that takes a string array as a parameter. It's just going to not know what to do with that. If you don't want to remember all that, IntelliJ has us covered on this one. Just type main and hit enter. And it'll give you a method that looks just like this with all the right syntax, all the right keywords. So that's the first case of where IntelliJ is going to kind of bail us out, where you don't have to remember public static void main string array. You don't have to remember all that. By the end of the semester, you just naturally will, just after using it long enough. But just type main in IntelliJ, and it'll do it for you. We're finally ready to actually do something after all that setup. All of that's just boilerplate. And now we can actually write some code. So we have our package declaration, we created a class, we created a main method, now we can write some code that's actually going to run when we run our program. For this, if we just want to print something to the screen, this can't be simple either. Java's got to add quite a bit extra here. Instead of just print line, it's system.out.println, and then give it the string that you want to print to the screen. That's a bit too. Eventually, you'll just memorize this, but it takes a while. But you can memorize S out. I like to think of this as string out to help me remember it. S out. Enter in IntelliJ, and it'll type system.out.println for you. And you just put what you want to actually print out. So another shortcut. So if you create your class, type main, enter, S out, enter. You'll get all that boilerplate code, and you can start doing some things. And all statements in Java end with a semicolon. This isn't as big of a deal as it used to be. IntelliJ, like if you miss a semicolon, IntelliJ is going to flag you down and be like, hey, look over here. You missed a semicolon. Just type semicolon over here, and we'll be good. Back before tools like that, it's called IntelliSense in IntelliJ. Back before tools like that, we had to hunt those missing semicolons down. Missing one semicolon could cost hours of your life. Hunting those down. I've lived that, and it sucks. These days, IntelliJ just, hey, you missed a semicolon, and it's good. But don't forget your semicolons. They have to be there at the end of every single line. Love it or hate it. It's a fact of Java. With JavaScript, this was kind of the case, but you get away with missing some, and JavaScript would be like, it's cool. Don't worry about it. Java will not run if you're missing one semicolon. Okay, any questions on Hello World? Oh, and just I forgot to remind the last lecture, but I do have chat open on my phone. As always, I have it open in every lecture. So when I'm looking at my phone, I'm just looking at chat. I don't think y'all have been saying much, though. No. The last message is from last lecture. Yes?
So let's say I want to create like another public class.
Mm-hmm.
Do I have to close this one first, or can I make the class within a class? Like, how does that work?
So you can make a class within a class. If right under public class hello world, open brace, I said public class goodbye world, open brace, I can define a whole nother class right there. We're not going to do that this semester because it just gets confusing and kind of awkward. So if you do want to create another class in this course, calling this a class gets confusing. But in this course, if we want to create another class, we're going to create a separate file. And then create another class in a separate file.
Also, I'm guessing like there's a private class and there's a public class.
Mm-hmm.
There's probably a difference. Like, what's the big difference between private?
Private means you can't access that from anywhere except within that file. There will be longer discussions about those, but I'm happy you asked. I'm happy to answer questions to get ahead. But private means you can only access that from in the file, any code inside that file itself, which is equivalent to inside that class. Which means like if we had private static void main, that ain't going to work for us because now Java from outside our code can't call our main method and our code can't run. I got to stop myself or go down a rabbit hole there. But we will talk about public, private, protected, and default. I don't know how much we're going to use protected and default, but I'll at least mention those when the time comes, when we get to inheritance week. Yeah, no problem. Any other questions? All right, let's keep on keeping on here. Variables and methods. So the code that I show in the slides, you can always find the code in the slides in the repo. So if you go to the repo, even though we don't know how to clone it and get that code into IntelliJ right now, you can still navigate the directory structure. Go to that GitHub link towards the top of the course website. Go to the SRC directory. Go to week 1. Go to variables functions. I haven't said that out loud. The name of the class. Go to variables functions and you'll find this code. But sometimes, and this is one of those cases, the code will be slightly different in the repo as in my slides. So I'll make some changes just to make my examples a little cleaner. So the code in the repo, I broke into 2 examples, and then towards the end of today's lecture, I'll combine them and give the code that's exactly in the repo, and then we'll look at the full example. But just to give this in pieces, just to not give too much code all at once, I broke this into 2 examples. So if you're looking at the repo, it is slightly different than what's on the screen right now. But we will get to the exact version that's in the repo by the end of lecture. So this program, we're going to start talking about variables, variable declaration, reassigning variables, defining methods, calling methods, a lot of juicy 115 content that's going to come and go very quickly. Like Friday is going to be conditionals and a couple different types of loops. Then next Monday is going to be our data structures, our sequential and key value store data structures. It's going to go very quick, all the 115 content. Again, I assume you're good with all the 115 content, so I'm going to highlight the Java-specific stuff for the most part. So here's a program that defines 2 methods and then has a main method. The main method is our entry point into our programs. This is where our code runs. This is where our code starts, I should say. So when we run this program, even though we have 2 methods defined and a bunch of code up here, the first line that gets executed is this line right here. We run all the code inside the main method. The main method's going to call our other 2 methods, but we always start with the main method. So let's take a look at this, and right out the gate, we get hit with a very major fundamental difference from Python and JavaScript coming over to Java, in that Java is strongly typed or statically typed, as opposed to dynamically typed for Python and JavaScript. What this means is that every variable in Java must have a type associated with it, and variables of a certain type can only store values of that type. So this variable, we're declaring a variable of type double, named num, and assigning it the value 2.4. That means this variable num can only ever store a double, where a double is a number that can have a decimal portion. So 2.4, that's a valid double. So this assignment is valid into a variable of type double. If I try to say num equals hello, it's not going to work for me. That code won't run. It's going to break things. It's just not going to work. In Python, that would be just fine. In fact, in Python, we don't even declare our variables. We just start using variables, and it's like, I know what you're doing. If you would just say num equals 2.4, num equals hello, and everything's fine. JavaScript, we did declare our variables. You either used let or const when you declare a variable. Hopefully they pounded it into your head that you never use var. There's like never a case where you should use var. Let and const, and that said I am declaring a variable, and then when you start using that variable, you don't use let or const. You don't redeclare the variable. You declare it once, and then you can reassign it as many times as you want, assuming you use let and not const. With Java, you declare using the type. So I want to create a variable type double, the name, and then assign it whatever value, and then I can reassign as many times as I want. But I have to stick with that type. Num can only ever store doubles for as long as it exists. So I'm declaring num type double, value 2.4. Okay, next thing, we got to call a method. This syntax is very similar to JavaScript. We have braces, indentation doesn't matter. As long as the code's in the braces, it's in the code block. But there are a few Java-specific things, most importantly, the typing. So we already talked about, so we're calling multiply by 2. So let's talk about the definition. We'll define multiply by 2 before we can really process that method call. Public static, we saw this in public static void main. Public can be accessed from anywhere. Static, we can call this method without any extra steps, which those extra steps will be object instantiation, we'll talk about in week 3. So public static, all our methods for these first few weeks, they're all going to be public static. You just get used to seeing public static. It's all our methods are going to be until we talk about classes and objects. The next thing, this is the Java-specific thing, or I shouldn't say Java-specific, but strongly typed language-specific. We need a return type. You didn't need this in Python, you didn't need this in JavaScript. In Java, you must define a return type of your methods. And it goes right before the name of the method. What this is saying when I say the return type is double for this method must return a double. Whenever this method is called, it will return a double. And when we define the method, we have to return a double. This is a contract we're signing with Java that cannot be broken. We must return a double if the return type is double. So if we look at the code, we're declaring a variable x of type double, and we're returning x. X is of type double, so we are returning a double in this method. So we satisfy that contract. If we weren't returning a double, if we said if we returned a string here, for example, Java's not going to like that. It's going to say, hey, you violated the contract that you signed. You said you were going to return a double, but you returned a string. Maybe fix that before we can move on. So I said I'm returning a double. I returned a double, so we're all good. But your methods must all have a return type, and you must satisfy that return type in your return statement. The name of the method, multiply by 2, there's nothing new there. For what it's worth, camel case, the first letter should be lowercase, and then camel case after that. Your input parameters will have names. This takes one variable named input. But the new thing for Java is your variables, your parameters must have a type. So every variable must have a type. That includes parameters. Parameters are just variables. So you must have a type. So I'm saying this method takes as a parameter a double. So it takes a double as its parameter. It only has one parameter, but that parameter must be a double. So whenever I call this method, I'm saying I have to give it a double. It takes a double. I do give it a double. Num is a double. So I'm good with that. It returns a double. Num, again, is a double. So I'm good with that. So everything's satisfied here. And of course, I use double for everything because we haven't really talked about other types yet. So it takes a double, returns a double. You need to specify your types. Strongly typed or statically typed, you have to have types all throughout your code. And I'm using double as a type here. And we finally, write code. You've written tons of methods by now. Nothing different here. We're declaring a variable. Again, that variable needs a type. When we declare it, we specify the type when we first create the variable. And then use a return statement. Return statement has to satisfy the type of the return type of the method. So we call the method, num is updated with the value 4.8, and we're going to print that to the screen. We've already printed a few things to the screen, so I think we're good there. Can a non-void method print? Sure. Or is it only supposed to be done in void? Any method could print. If in multiply by 2, I want to print, I got the input and then the value of the input, and I computed x to be whatever x is, that's perfectly valid. You can print from anywhere. And then we have this method y, because, bless you, because why should this method exist? This method's really dumb, but just to show you that this concept, we can have a method that doesn't return anything. If we have a method that doesn't return anything, we set it as a return type to void, which means this method doesn't return anything. If it has return type void, we don't have to return anything. We shouldn't return anything. And you notice I don't even have a return statement anywhere. Just when we hit the closing brace of the method, that's when the method ends. There's nothing to return, so there's nothing to say, this is the end, return this value, and end. It just hits the end of the code block. Void methods are called for what we call side effects. It's not returning anything. We're not saying, here's some input, process this input and then give me some output. We're not doing that. We're not asking to process anything. We're just calling it for its side effects. In this case, the side effect is printing to the console. That's why we would call this method. It really shouldn't exist. This is just an example to show you what a void method is. And then when we get to classes, we'll see that we can actually do things, useful things, with methods that return void. But for now, it's nice to just know that these exist, and then we can leave it at that. But we would only call these for their side effects, not for their return values. Whereas multiply by 2, we're calling for its return value. And then when we hit the end of the main method, program ends. That's it. Any questions on this example? Moving on. All right, so we mentioned types, but I only mentioned one type just because I wanted to keep the first example a little cleaner. I only mentioned double. So let's talk about some types: double, string, int, boolean. These are 4 types that we're going to pretty well stick to for the first couple weeks of class, aside from our data structures. But we'll have data structures of these types. So let's talk quickly, briefly about what each one of these is. Double, we saw in the previous example, this is a number that can have a decimal portion. So our 2.4, that's a double. It has a decimal portion. Even if the decimal is 0, like if this was 2.0, we would still put the 0.0 to make it clear. Technically not required, but to make it clear that it is a double value. This is called a floating point number. In fact, float is also a type. It's just a type that we're not going to see or use in 116. Similar to double, double just has, you guessed it, double the precision, double the bits. Double is a 64-bit floating point number. Float is a 32-bit floating point number. But this can store a very, very wide range of values, close to, I can't say that. I was going to say close to infinity, but that's kind of meaningless. It's not it's not helpful. But very, very large numbers and very, very large negative numbers as well. Positive, negative, very wide range. But the numbers aren't always represented exactly as you would expect them to be, which is a foreshadow to next Wednesday. We're going to see why that's actually important. For now, doubles can have decimal points. Strings, you've seen these. I don't want to dwell too much on it, but it's a sequence of characters. Char, C-H-A-R, is another type that we'll use when we're handling strings one character at a time. You might see those pop up. But other than that, note the capital S, where we have lowercase d, lowercase I, lowercase b. For the other three types, capital S. That's another thing that'll be very important, very relevant later. Day one, I don't want to get too lost in the weeds on details, though. Int, this has to be a whole number. So it's kind of like double in the sense that it is a number, but it has to be a whole number. And there's a much shorter range of values. These range from roughly negative 2.14 billion to positive 2.14 billion. Once you go outside of that range, you'll get either an integer overflow if you go above 2.14 billion, or an integer underflow if you go below negative 2.14 billion-ish. If you watch speed runs like I do, they talk about int overflows. They'll break games with integer overflows or sometimes underflows. That's usually what they're talking about. They have some integer value, either an int or usually a byte if it's like a NES game. They'll just have 8 bits for the value, and they'll go over 255, overflow it. Or if they have a 32-bit int like we have here, and they go over that 2.14-ish billion, it'll overflow, and the value will be reset if you go over that value to the largest negative value, which is usually not what you want, unless you're trying to break things. So if that happens in your code, it's just something to keep in the back of your mind. We shouldn't run into that in 116. Everything's carefully designed to not really expose that limitation. But something to keep in the back of your mind that integers can overflow, and very bad things happen when you're expecting 2.5 billion and you get negative 1.8 billion-ish. Almost certainly not what you want for the behavior of your code. When you're dividing two ints, the result is always an int in Java. So we have 6 and 4. These are both integer values because we didn't say a decimal portion. For example, if we did 6.0, this would be a double, and then we could divide without what we're about to see. But 6 divided by 4, those are two integers divided by each other. When you divide two ints, the result is an int, which means the result cannot have a decimal portion. And Java will just truncate the decimal portion, effectively taking the floor of that decimal portion. So 6 divided by 4 isn't going to be 1.5, it's going to be 1. Because 1.5 isn't an integer, it's going to delete the 0.5 and just give you 1. Even if you're very close, it'll always take the floor. Even if you're very close to the next number, you're not getting 0.99 here, you're getting 0. It just deletes the decimal portion, effectively taking the floor. So something to keep in mind, if you have two ints, you will get an int as a result. We call it integer division. If that's not what you want, get one of those ints to be a double, and then do your division, and then you'll get a floating point number as a result. And Boolean, I don't have much to say about Booleans. You know what Booleans are. For what it's worth, lowercase t, lowercase f, unlike Python, that had capital T, capital F. Any questions on types? Yeah?
Can I declare like a double as 6, or does it have to be 6.0?
You can declare a double as 6. So the 6 is an integer, but when it's assigned the double, Java will automatically convert it to a double for you. That's one automatic conversion that we can rely on, converting ints to doubles. But we can't go the other way around without, at the very least, getting warnings in our code that we're going to truncate the decimal portion and lose precision. But int to double is always fine. For example, our method in the previous example that took a double, if we gave it just 5 without any point anything, it'll be fine with that. It'll be happy with that. Any other questions? All right, let's do this. Memory diagram number 1 of the semester. We're doing this right from day 1. Paul's doing the same thing. We want to get memory diagrams out there right away. So this is very similar to what you'll be doing in lab, the memory diagrams you'll be doing. So we want to introduce what these things are right away. And this is where I'm going to be synced up with the code in the repo. So this is the exact code that you can see in the repo if you're following along in the GitHub repository. So it's the previous 2 examples just mashed together, and I added back in the things that I removed to simplify the previous examples, namely the int val in the method y, and rename the variable names. So we're going to trace through this code. When we trace through with a memory diagram, what we're doing is showing exactly what's happening in memory when a computer runs this code. So we are mimicking what the computer does when it gets a hold of your code. When it gets a hold of this code, what does the computer do? Or more specifically, what does the JVM do? But I haven't introduced that yet. So let's see what it's going to do. So this could be a quiz question. Probably not this specifically. This is an awkward question for a quiz. It's really designed to be a lecture example and hit the different types and return types. But we could give you a chunk of code. We'll give you a chunk of code like this and say, draw the memory diagram. That's what your quizzes are going to look like. Let's talk about what a memory diagram is. So, how does a computer store values in memory? First, there's going to be the memory stack or the program stack. This is where your variables are going to be stored. The stack is going to be split into two columns in our memory diagram, a name and a value, and this is how the computer keeps track of all your variables. The name is the name of a variable. The value is the current value stored in that variable. So the stack is going to store your variables along with their values. And this is somewhat of a lookup table. Whenever you use a variable, the program is going to look up in the stack and say, okay, they're using a variable named num2. What's the value of num2? And it's going to find the value and then use that value. The variable resolves to that value based on looking up the value in the stack. The heap is something that exists, and it's a conversation for another day. But I want to show you the whole memory diagram layout, the structure of it today. Don't worry about no heaps yet. And then we're going to have a section for in out. We're going to use this for out. This is where everything that's printed to the console is where you're going to put it. You can put it wherever you have room in your memory diagram. Since I know I'm not using the heap today, I'm going to put it over in the heap and take up some of that space physically on the slide because everything's going to go on the stack today. But wherever you have room, we'll have some heap-heavy examples and heap-heavy quizzes later in the semester. Then you might want to put in out over in the stack area or off to the side. It's up to you. We're not going to specify where to put in out. Program always starts with the main method. So even though we have code up here before the main method, the code always starts right after the open brace of main. And the very first thing that we do is print to the screen. So we put that over in our in-out section. In our first variable declaration, we're going to put num equals 4 on the stack. Name num, value 4. Nothing too mind-blowing, I hope. But we're going to put the variable name along with its value on the stack. Note that we're not caring about the variable type. Like we just trust that we all know what the variable type is. If you're looking at this code, you get to the point where you can set all this up. I'm confident you know that num is an int. So just to reduce some clutter in our memory diagrams, we're not going to put variable types in our memory diagrams. Just name and value. We're going to declare num2 with 2.4, string 1 with a string. Don't forget about your integer division. 6 divided by 4 is 1 in the world of integers, not 1.5. Bool equals true. Print I am num3, colon space 1 to the console. And we get to our first method call next. So any questions on the setup of a memory diagram before we get to this beast of a method call? I don't think there's anything too mind-blowing here, but if there are questions, I want them now, or else this method call is going to be way too crazy. Nothing in chat? No hands going up? All right. We're feeling good. Let's call a method. When we call a method, we're going to add to the stack what we call a stack frame. And this is going to be an isolated environment for that specific method call. So this is going to be a section of the stack that's only accessible by the method. and not accessible from anywhere else in our code. So for example, when we're in the stack frame, we can't access any of these 5 variables, and from outside of the stack frame, we can't access any variables that are inside the stack frame. It's a separate section of the stack just for the method call that we call a stack frame. So when we call a method, we're going to create a stack frame, and that's our environment, our section of the stack for that method call. We're going to denote this by a solid box in our memory diagram. Solid to denote that we can't cross those lines. When you're inside a stack frame, that's it. You only have access to everything inside the stack frame. If you're outside a stack frame, you only have access to what's outside the stack frame. So we write a solid box to section off our stack. I already said all that slide. We're going to have the name of the method being called written off to the side. We're calling multiply by 2. So I'm going to put multiply by 2 off to the side. So this is a multiply by 2 stack frame. And we're going to draw a return arrow showing where the return value of this method call is going to go. So when we call this method call is going to resolve to a value, which will be of type double. That value is going to be assigned the variable num2. So I'm going to draw my return arrow going to the variable num2. And when this method does return, we're going to update this value for num2 with a new value. And stack memory will be updated to say that num2 has that new value. And the old value is no longer stored in that variable. Then the input parameters. The parameters are variables. The parameters are going to be assigned the values of the arguments. There's just one parameter, one argument in this example. So double input, we're declaring a variable named input. Parameters are the first variables that are declared inside the stack frame. So only this method call has access to this variable input. It's going to be assigned the value of the argument. So the value of the argument, num2, when the computer tries to resolve num2 to a value, it does not look at your code. It doesn't care what's going on here. It's going to look in memory. Okay, what's in the stack right now? Num2 has the value 2.4. So input, declare the variable input and assign it the value num2, which is 2.4. So input equals 2.4. In 115, whenever I teach 115, I call this the hidden assignment. Double input equals num2. That's kind of split across 2 lines of code, but it's one assignment operator, just the same as saying double input equals num2 all on a single line. The memory diagram, I think, makes it more clear of what's happening there. We're actually declaring a variable named input, assigning it whatever the parameter resolves to, 2.4. We're not like moving num2 down here or anything. And then any variables that are declared inside that method during the method call are declared inside the code block. We'll talk about code blocks on Friday. Inside the stack frame. So x being declared inside the method call. This method call is inside the stack frame, so that variable goes inside that stack frame, meaning that variable x can't be accessed from outside of the stack frame. And again, we can't access any of these variables from inside the stack frame. Now, from 115, a lot of that's probably kind of intuitive, like you've felt like functions work like this, that they get their own isolated environment. This is what's actually happening in memory, though. We're actually sectioning off a chunk of the stack with a stack frame to be able to get that isolation of a single method call. For example, if you call a method twice, that's why you can reuse variable names. There will be 2 variables named input, 2 variables named x. It's because they're in completely different isolated environments. So when you say x or input, the computer knows which one you mean. It's the only one that's inside that stack frame for that specific method call. And it's why after a method call ends, you can't do system.out.println x. Oh, we didn't even get there yet, but we will. When a method returns, we have return x. Whenever we return a value, we're going to follow that return arrow. Return x resolves to 4.8. We'll follow the return arrow that we drew earlier. 4.8 is assigned, num2 is assigned that return value of 4.8. So when we update a variable's value, we're going to cross out the old value and write in the new value. So num2 now has the value 4.8. And when a method call ends, what the computer does, what Java does, what IntelliJ does, what the JVM does, is erases the stack frame from memory. When a method call returns or a method call ends, that stack frame is destroyed, it's erased, it's removed from the stack. And to denote that in our memory diagrams, we're going to cross out the stack frame. So method call ends, cross out your stack frame. Input and x, those variables no longer exist. They're gone. They're erased from memory. Absolutely gone. And the only memory of that method call is the fact that num2 updated to 4.8. And after going through a stack frame and a method call, we're just going to print to the screen again. Get back to a simpler time. We're going to print new num2 4.8 to the screen. And we have another method call. This method call, this why, because why should this method exist, returns void. So we do the same thing as multiply by 2, except we have no return arrow because there's nothing to return. We do have an input named val, which is going to be assigned the value of the argument 2. Except we don't even use that variable. That parameter shouldn't exist at all because we never use it. It's a pointless method, but it's used to emphasize this is a method that returns void. It's going to print to the screen. And then when that method call ends, it doesn't have a return value. So once we get to the end brace, that method ends, that stack frame's erased, and val, that variable, is no longer on the stack. It's erased, doesn't exist. That stack frame is erased. Stack frame doesn't exist either. We reach the end of the program, and our memory diagram gives us the whole history of the program execution. What happened when this program ran? Well, everything's right there. All the information is right there. We had 2 method calls. We can see the stack frames. We had a reassignment of num. We had 4 things print to the screen. It gives us all the information of the program running. And for your quizzes, we get this from you, and we can tell whether or not you understand how that program runs and what happens in memory when it runs. Any quick questions on that? Oh, don't close your laptops yet. No questions? All right, we have our first of many lecture questions. Woo! So Autolab is active. If you go to the course website, the very top, the first link is Autolab. If you go there, there will be an assignment called Wednesday. Let me actually go to it. We got 3 minutes, so we got time to do our very first lecture question demo. So you go to Autolab, Wednesday, Feb 1, and you'll have your multiple choices right here. Select the answer that you think it is. Tell me you didn't cheat. Click Submit. You only get one shot at lecture questions, so don't accidentally submit something else. I'll probably be pretty lenient, honestly.